the cybersecurity risk that goes along with kind of opening and exposing the business aspects. Fundamentally, what we're going to focus on is looking at purpose-built technology can really provide for that combination of the solution of cybersecurity, protection of the APIs, and how to optimize that through intelligent caching optimizations. So, the focal point of purpose-built technology is really fundamental to the various environments. Certainly hardware-based, traditional, but software-based, virtual, cloud are all parts of the ecosystems where APIs and business transactions can effectively live. And that's an important distinction, because really what we have to look at fundamentally is what does modern network traffic, what is a business API? If we look at it, we crack open the wire and take a look at what really is flowing. That's the fundamentals of where the evolution of the technology that can solve the sort of the ability to broker that comes from. This is really driven, fortunately, through the evolution of many of the last few years of standards bodies like OASIS and W3C and IETF and open standards. What that is built is basically a framework of messaging and formats that is at least known standards based. So part of the ability for the evolution of a lot of the technologies and API capabilities it was born out of adoption of standards. If we look at it really in terms of the evolution, we started years ago with web services and starting to sort of get reusable components, and that gave way to SOA and service architecture type paradigms. And in parallel to that, virtualization came onto the landscape, showing ways by which to virtualize infrastructures and virtualize systems. And obviously cloud computing has then taken that to the next level to really allow the infrastructure and platform virtualization as well. But the evolution of all of this has also evolved to a standardized set of data formats, where standardized data really dictates a lot of the ability for these various different types of infrastructures and vendor components and trading partner infrastructures to utilize standards-based data formats and identity formats and message formats, where that ultimately gives way to what, even though where the standards base effectively looks like what you now see in the modern day network across all of the various vertical industries and apps and basically different aspects, all fold into really fundamentally standards-based message patterns. And this is key to now how the evolution of that focuses on the ability for technology to play a more crucial role at the edge of the network with regard to brokering and facilitating the communication of these various types of modern day applications and traffic. So with that really is the focal point of security and enablement, how an API security gateway can provide both. At what we call the edge. You heard Randy from Forrester talk many times about the edge. The edge can mean many things. In the traditional sense, of course, it's the DMZ, the corporate boundary, but it also means effectively the frontline boundary of where your data transfers are occurring. And a boundary could be your cloud provider, public or private cloud provider entry points. You might have a virtualized container, a VMware virtualized container, where that boundary is effectively the communication in and out of that virtualized environment. You might have internal networks where your segmentation is based on security zones, and that edge boundary is the difference between data moving from one zone to another. So when we talk about edge, it does have different aspects of connotation. Traditionally, it's the perimeter of your network, the first line of defense, but the boundary is effectively wherever upstream, that first border, if you will, between some other environment or ecosystem into another. So when we look at that and how we then focus on what API security looks like from an edge deployment perspective, we've got, on the infrastructure side, all the different variants that have evolved in terms of what service and data exposure means. Mobile services, portals, REST services, SOAP, XML, traditional FTP, SFTP, are all parts of those data flows that are externalized through business APIs. And of course, your consumers coming in have many different variants of mobile apps, users, portals, B2B infrastructure, third-party integration points. Obviously, the cloud provides that. With that comes many different richnesses and different variances of identity formats that come in through that boundary. And so what we want to do from an edge deployment perspective is broker that across the various different protocols and focus on that modern service traffic, all those different variants that have evolved, but are framed within standards, within known standards and formats. And it's there where we look at focusing on technology deployment where we can provide secure mediation capabilities by way of presenting the API, presenting the business flows, enabling those business flows, but doing so in a way by which the security and identity aspects that fold into cybersecurity protection, but also enable the ability to expose those services broadly, and those APIs can be presented and exposed across a much broader spectrum of consumers in a secure manner. So the edge deployment ultimately looks like that. Now, in order to play at the edge, ultimately the security pedigree of the solution in question has to be solid. If you're playing at the edge, in other words, you have to have secure technology in order to do so. So one of the fundamentals are hardening the system by way of various mechanisms, ensuring that the infrastructure and the architecture has certification so that in itself isn't a target for attack. We talk about security at the edge. The system in the product technology itself needs to be hardened to the degree in which it's going to be a target for attack. And so fundamentally focusing on the necessity to harden that solution in order to provide the data features and the business features and the capabilities in the industry. The starting point of all of that is ensuring that the actual technology is in itself secure so that it can actually be deployed physically by architecture design at the edge. And that's the key. When we talk about deployment at the edge, the core of that is fundamental to the ability for the target solution to be certified to be able to be secure enough for that type of topology and deployment. So when we focus on now the ability to do a lot of these aspects of business enablement and API enablement at the edge, we look at the core feature set. The four key aspects of what goes into technology that can facilitate this. First of all, we know in the modern era, cybersecurity is a real entity. That ultimately threat detection and prevention is a necessity in business enablement. They need to be coupled together. We can't just expose and open our businesses and our APIs and our data to anyone arbitrarily, because there's many different reasons why the privacy aspects, infrastructure, it can be damaged through, without the securing. Obviously, there's many aspects of the necessity for security. Additionally, the ability to identify who's going what and doing what in terms of communicating in and out of those boundaries. Data conversion, protocol conversion, and edge response caching, message caching are all core to what an API security gateway can do at the edge. So if we look at each of these in the spectrum of what that means, cybersecurity threat detection prevention looks and focuses at threat mitigation, which it looks at contents and antivirus scanning and rates, privacy, ensuring your data is basically encrypted or decryption, and integrity for structural conformance and perhaps digital signatures, accountability to see who's going what and doing what, are all part of focal point of that API, central API vetting point to provide the threat detection and prevention capabilities for modern formats, for those data formats, for those formats that traditionally go through existing security architecture undetected, on known ports, on known IPs. Streaming packet analysis isn't good enough to look and inspect the characteristics of these types of modern day business transaction patterns. The focal point needs to be at the content layer of the messages and focus on those aspects from a security perspective. From an identity and single sign-on perspective, similarly, the ability by which to identify who it is that's coming in. And again, because you've got such a diversity and complexity of inbound consumers, the identity formats span across a broad spectrum of message and protocol-based credentials. The ability by which to enforce access control, who gets to go where and do what. Single sign-on is a very important aspect for the user experience by way of enabling a credential authentication and then a seamless user experience or transaction sequence where that initial authentication leads way to sessions and the ability by which to not force re-authentication and enable more single sign-on capabilities to have a more seamless business experience with those APIs and that infrastructure. So identity and access control and SSO are a fundamental part really of enablement of business APIs in addition to just the cybersecurity protections. The ability by which to present APIs and information externalized to other consumers leads the way to the necessity often to convert data formats or present APIs on different protocols, because as Randy was saying earlier, there are certain technologies on the client side, like mobile devices and other infrastructures, that are limited to some degree in what capabilities, just based on the systems, the OSs, the actual devices, if it's a mobile device, whereby certain applications maybe can only do SOAP or only do XML or only can do REST or only can do HTTP, and your infrastructure services may have been designed and built with other things in mind. So the ability by which to present that API, again, in a secure way, may mean that you also do so on a different protocol or on a different message format and convert that data flow from one side to the other with regard to providing that mediation. And again, expanding and broadening then the horizons of integration points where that doesn't require reworking all of the internals of the services, but rather simply exposing those on APIs using intelligent mediation and on the protocols that are supportive of those clients and of those environments that you want to connect in. Now, the notion that we talked about and was mentioned earlier around edge caching is also an important aspect of this optimization of edge-based deployment, where ultimately and fundamentally caching has been around for a long time. Caching with regard to proxies and caching for data. But when we talk about edge caching for API, it's a different game, because this involves a much richer spectrum of message patterns and a much richer spectrum of necessity to what a cache engine must do to enable optimized access to flows and responses. So it really focuses on the standard aspects of what API gateway technology is fundamentally in charge of doing anyway, which is brokering communication patterns from consumer to your internal environments. And brokering that in the way of focusing on various aspects of what's coming in from a request perspective. It could be a SOAP message, XML, a REST, JSON, HTML. And we're focused on enabling, of course, that transaction by way of the traditional and standard mechanisms of security and identity and flow control. But taking and focusing on the identity formats, characteristic attributes of the request, for the purpose, of course, of again enabling that flow to go to the back-end infrastructure to consume those services. But layering on the intelligence of that to further look at and focus on, again, characteristic aspects. We see what's in the header. We see what's in the body from a gateway perspective, what's in the message patterns, and using those intelligently as keys to a cache engine where you can couple information from the user's identity, specifically from the header, from the message request, in ways by which to then correlate that intelligently so that the focal point of the response as it comes back from that infrastructure is brokered back to the client side. That's also enabled to be stored and kept hot, if you will, internalized to a cache engine, which keys off a much richer context. It's not just static, arbitrary caching of all content. It's caching individual content based on the consumer, based on the characteristics of that inbound request, most specifically on the richness of identity, on the richness of the request data, which characterizes the flows to be cached intelligently and specifically to those B2B environments or users or mobile devices that are coming in, and specific to those users and those sources, such that when subsequent requests come in with those same characteristics, the redundancy of nature of those API flows can be characterized, represented, identified by Sentry, and then provided for a response cache at the edge. What this does is dramatic reduction of some of the I/O latency and redundancy in many calls that actually happen from the infrastructure. So if you look at things like, static content, of course, images and CSSs and JavaScript and login pages, but these may be also specifically based on the credential, based on who you are, and based on what kind of system or device you're coming in from. So it goes a little beyond the traditional static sense, where the characteristics of how you cache that information may be specific to who it is that's asking for it. But there's still a significant amount of redundancy. If you think about, for example, a mobile application that's being hosted, and you have 10,000 devices, cell phones coming in, requesting that information. It's a significant amount of redundancy involved in presenting back those same kind of objects, those same kind of information. But more importantly, the dynamic aspect. Things that have deterministic responses, like conversion services. If I have a numeric converter or a temperature conversion, the answer to the question, what's 10 degrees Celsius, is always going to be the same degree Fahrenheit. So those types of services, which are deterministic in nature, are eligible aspects for caching. Lookup services. Things like authorization calls that have some duration of time where that answer to the question is going to be the same for the next 5, 10, 15, 20 minutes. And rather than continually having redundant calls, utilize that intelligent caching, advisories, news, things that may be dynamic in nature but static in duration are eligible aspects. And where the edge caching really can be significantly enhancing is, again, reducing the impact on the infrastructure with regard to how much additional overhead of redundant processing, the network I/O impact of continually serving that content from all the way back into the infrastructure, by leveraging a lot of the technologies that already exist in the security, identity, and brokering capabilities of API security gateways, and leveraging that from an intelligent edge caching can really be fundamental to optimizing the flows and really accelerating how those business APIs interact and can go. So, in closing, ultimately, I want to thank Randy Hefner from Forrester Research for his participation today in framing what the market challenges and opportunities are around strategies. The modern business API does have the characteristics, again, of cybersecurity and edge caching. And we encourage you, and thank you for being present today, and encourage you, if you'd like to learn more, to visit our website at www.forumsys.com. And again, thank you everyone for your participation today.